Hello everyone. So today we've built a solution which is cognitive uh, agentic architecture based on a certain architecture which is being used today by the likes of Claude, Perplexity, and the tools that you see. Uh, this is a architecture where there's one agent which spawns others and kind of guides them what to do and what how to reach to the final goal of a problem that needs to be solved for the user. So I'll first take you through the flow and then we'll see it working also. So once a user fetches a query or gives a query, the iteration starts, the agentic iteration starts. The first thing it does is reads a memory, which is a persistent memory. So something like your preferences or your mom's birthday is stored in there. Now there's this agent which is called perception, or I am calling it perception, looks at the query, looks at the memory saved, and decomposes the query into atomic goals, right? And in the first iteration, of course, it'll mark all of it open. And the agentic loop continues to run till the time all these goals are satisfied, right? So that this is the condition which uh, governs if the loop is done or not. So if all goals, of course, in the first iteration are not done, so we'll go through a flow where we pick the first goal which is open. If we have an artifact which is connected to this goal, we'll pick that goal and give it to the second agent. So this agent is the worker agent, right? It will be given a goal. It will be given some information, and on its hand it has a MCP with several tools, so that it can call those tools or decide to answer the query depending upon goals and artifacts it has, right? So if it says that I can answer the query directly, it'll give a direct answer. If not, then it will give you a tool call from the MCP server, right? So MCP server will do its thing, and this flow will continue, right? Uh, while going back to the flow, we will see that if we have read something which is really useful and we need to write that into our persistent memory, that is where this memory comes in. So if there's a small agent which lives here also, it decides that this is something that we should save, and we add that as a fact uh, or a line item in our memory, and we start with the next iteration. The iteration goes until we have all goals done. When the all goals are done and we have an answer, we go to the user and say this is the answer, right? If not, so let's say all goals are done but we still do not have an answer, then we go back to a synthesis fallback, which is another cycle of perception which helps it decide, yes, this was the goal, this is the information that I got, now I have to draft an answer for the user, and that is where the user goes. So this loop that you see is also kind of a fallback if let's say our MCP server is not working or for some reason our LLM calls are not working, it's a fallback. It tries for some time, but if it feels it's still stuck, it will go to the user and say I'm stuck. Uh, Try again or something like that. Also, if a decision has an answer to the whole all the goals, it can spawn an answer there, right? So this is the architecture. Now we'll quickly run a few queries and show. Uh, so let's go here. So let's run the first query. So it'll take its time, and you'll see all the loops that are working. So this is the iteration one. Perception decomposes the query into tasks, and these are two tasks: fetch the Wikipedia page, extract birth date, death date, and three contributions. So that's happening. Goes to decision. Decision says that User provide a specific URL to fetch, and I will call a tool to fetch this URL. This creates an artifact with an ID, goes back to the iteration 2 into 2 to perception. Goal 1 is done, right? And then goal 2, sorry, iteration 3 happened. Goal 1 is done, goal 2 is extract things from the artifact. So now decision is getting the artifact, the open goal, and the history of the tool. It says I have extracted the requested information, blah, 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 and I have the answer. This is the answer. I've added another call to make sure the answer is there, the answer is correct, just to check if everything is sorted. So it checks all the two goals are done for another iteration. And this is the final answer that you get. And you get a run summary with it. So this is the run summary. The iteration one fetched this URL, log file has this, and all the information that you can see. So now let's run the second query. So find three family-friendly things to do in Tokyo this weekend. Check the weather and tell me which is appropriate. Let's see. Opens a log file, iteration one. So iteration one, perception decomposes, create three goals. All three are open. Then we use web search because we want to find three family-friendly activities. Tool call is web search. And then we get something back, which is an artifact with this ID. Perception again in the iteration 2, goal 1 is done to open. We give the decision a goal, second goal, and the artifact. Second goal is check Saturday's weather. So it does a web search to get Saturday's weather and again records that as an artifact. Now in the iteration 3, two are done. Now it needs to combine these two and see what's the best solution, right? So yeah. So decision is saying I have identified three family friendly, blah blah blah, and check the weather. And decision has made an decision, an answer that Saturday this is the weather in Tokyo, and the weather forecast is sunny, and blah blah. So in the next iteration, this will go back to perception, and the final answer will come out. Yeah, so iteration 4, and finally in iteration 4 we get the whole answer where you should go, and then we get the run summary. Right. Likewise, we have two more queries which test more capabilities of this cognitive agent. Now we will test the memory part of it. So this is a query. So I'll probably pause and we'll wait for the result and I'll take you through. So this one took some time and it's very interesting because this time the first thing it does is from the query it identifies that there's some information which needs to be saved in the memory, and it does save it in the memory. If you look at this memory.json, mom's birthday, right, 15th May. So it does that. So which is good because we need this to remember this, right, to be able to do this, run this query. Now then perception decomposes, creates only one goal, calendar reminders on 15th May and 2 weeks before. Now decision says that it needs to create reminders, which means it needs to create a file. So it kind of searches for the directory if there are already existing files. So I should start by checking the directories. The first action it takes is list. Now it there's a file that existed, pickup kit text, which was from a previous query I tested. It got that, it understood what's the structure, Now the goal one remains open. Decision is creating a file, create file tool, and writes it in there. But the interesting part is there is no answer, right? So that's why the final loop comes into play, right? The goals are done, but no answer is there. So it is running a final synthesis, right? And gives the answer. I successfully set your reminder, mom's birthday, and file name, blah blah blah. And that's when the loop ends, right? So now we go to our final query, which I hope should be quicker. Oh, we need to also ask when is the mom's birthday so that we can check if it reads the memory. So I pause and get back. So like you see, it quickly read the memory and got a fact from there, which we had written in the previous loop. So if you see this memory.json, which we saw, and the persistent memory where we wrote the reminders, the two reminders, but it is picking from this memory, mom's birthday, and the goal is provide mom's birthday. Decision says the required information is there already in the fact. The decision has been passed with facts. Also, no external loop is required. The answer is direct. Now this is where the extra loop costs me because it'll run another loop to make sure that the answer is there. In the previous run, the extra loop was helpful, but in this run it's repetitive. Maybe I can build a scenario where I do not have an extra run or have an extra run only when the answer is not there. So that's something that can be improved. But we have one more last query, and we'll probably wait for this to get done. Oh, got done. Okay, so yeah, all goals satisfied. Final answer your mom's birthday, and it is summary. Now let's run the final. It says search for Python async best practices, read top 3 results, and give me a short numbered list of advice they agree on. So we can understand by now that we'll decompose it into goals, call a few tools to find out async IO best practices, and then maybe have another loop which synthesizes this information, and one final loop which gives the answer. So we can see we have perception decomposing into multiple goals. We have web search query, creates an artifact, goal one done, two open, fetches the artifact, gives it to decision, gives the answer based on uh, the artifact that it read and understood. Uh, Update all goals are marked done, and then it gives an answer. This is the answer. Like first and advice is this, second is this, and then third is this. Took comparatively much lesser time than the previous one, but this is how it is. So this is the agent on basis the same architecture. There's so many improvements that can be done, yes, but let me know your thoughts. Thank you.